Hi, I'm Helen Ju from the MVMS Robotics team. In this video, I will be talking about the IR sensor and the color sensor and how we use these in this year's FTC challenge Cascade Effect. Okay, so in Cascade Effect, we had to score balls, and before doing this, we had to release the balls from the center station by knocking down the kickstand. So here's the center station and the kickstand's right here, and we decided to do this mission during the autonomous mode so that we could get more points. And we would start from the parking zone and we just come up and knock it down. And then the center station has 3 different positions, and that means that the robot needs to be able to perform different movements for each in order to knock down the kickstand. And in order to know what movements to perform, the robot needs to know what position the center station is at. And on the center station, there is an IR beacon. It can look like this or like that, and it's mounted on the blue board, and another one is also mounted on the red board. So what an IR beacon does is that it flashes an infrared light, and these IR beacons are set at the 180-degree mode and flash at a 1200 Hz frequency. And the infrared light can be sensed by an IR sensor. So this is what can sense right here. This is the IR seeker, and it can sense the infrared light of the IR beacon. So this is basically how it works. There are 5 sensors on the IR seeker, and the directional information is determined by which sensor sends the strongest signal. For instance, this is sensor 1, and if sensor 1 sensed the strongest signal because, let's say, an IR beacon was right here, that means that the directional information would be 1. If sensor 2 sensed the strongest reading, that means that the directional information would be 3, and so on according to this table. And we found out that in testing that the IR sensor had to be 2 feet away from the center of the center station so that it could sense the readings of the IR beacon. And then this is a RobotC sample code. It was used to identify the center station positions using the IR sensor. So the first line right here, it defines the variable IR to represent the high technic IR seeker, and it is connected to the NXT port S3. Then right here where it says sensor value IR, it is used to find the directional information of the IR source. And from our testing, when the sensor value is 5, the sensor station position is 3. When the value is 3, it's position 2, and when it is 0, it is position 1. And that's it for the IR sensor. Okay, so now for the color sensor. The color sensor senses color and light intensity. So the color is sensed as a code. Black is 1, blue is 2, green is 3, yellow is 4, and so on. And then for light intensity, it is from darkest to lightest on a scale of 0 to 255. And at first we wanted to use the color sensor because we were afraid that after our robot would come down this ramp, it wouldn't be aligned anymore. And for one of our autonomous missions, our robot goes down the ramp and then scores balls into the goals. But then, since it's during the autonomous mode, there's nothing we can do if it comes off unaligned and misses the goals. So in order to have it aligned, we decided that once the robot comes off the ramp, it would back up, and then it would align to this blue line right here. And in order to know where it is, we need the color sensor. So that's what we were going to use it for. And here is a RobotC sample code for the color sensor. Basically what it's doing is that it has all these cases. If there's a black color, then on the NXT line 4 just display black. If blue, display blue on line 4, and so on. This code was basically used to see if the color sensor could detect the colors red, blue, and gray, because those were the colors of our playing field. And that's it for this presentation. Thanks to Coach Bhaskar, Coach Dawe, and my team members, Saharda, David, Brandon, William, and Alvin for their help in developing and testing the IR sensor software.